Speaking of that, the second talk will be from Demetra, Lytras, Lar James, Samantha Nguyen, and Aaron Rona. They will talk to us about testing for changes of seasonal patterns in Census Bureau time series. This will be a 35-minute talk, by the way.
There we go. Hi, everyone, and welcome to our talk about testing for changes of seasonal pattern in U.S. Census Bureau time series. I'm going to introduce the topic, although you just saw some applications of it by the Lytras here, and then I'm going to turn it over to our other presenters to talk about, and they're going to talk about the results from testing for these seasonal patterns in some U.S. Census Bureau surveys. So when we have these events like the recent pandemic, the recession back in the day, or even just if something big happens to change how the data is collected, people start to wonder if there was a change not just in the level, but also potentially in the seasonal pattern itself. And in X13, we have change of regime seasonal regressors that we can use to test for such a change. Really briefly, seasonal regressors in X13 are designed like this. So they're like seasonal dummies, but they're constrained to be 11 for monthly or 3 for quarterly effects to avoid issues with differencing and singularities with the constant effect. So in X13, when you have regression effects and you difference your time series, the regression effects are also differenced. This means that seasonal regressors can't be used over the full span of data because with a season, when there's a seasonal difference, because the seasonal difference will zero out this effect. This is my example series for this presentation. It's just a simulated quarterly series from an airline data. And you can see here in the middle of the series, what I call 2010, there's an induced pattern change. So really quickly, here's what the seasonal regressor looks like. And then if you run the model, this simulated model with a time series, notice no seasonal differencing, plus the seasonal regressors, we get an estimate for each of the 3 quarters. We get a derived estimate for the 4th quarter, and then we have a test for the significance of the group, and p-value is 0.00, indicating that the group is significant. In X13, we have change of regime seasonal regressors. There's 2 types of them. The first we call the full test, the full change of regime. This puts that full set of seasonal regressors in, but then it also puts in an additional set of regressors that are 0 on or after the date of the change that you provide. The other 2 types are what we call partial change of regime seasonal regressors. They're going to be 0 either before or after the date that you provide. Double slashes means that's where the zeros go. And then there'll be a test to indicate whether that second group, that change group, is significant, and that's what we look at to see if there's a change in the pattern. There's more information about these regressors in the manual and also in this paper, although it talks only about the full change regime, not the partials. So if we run our simulated series with the full change of regime, as we see, we have estimates for our for the seasonality in the series, essentially, is what this first one does. And then this one, the second set test for the change for before the date. And then we have p-values. And here we look at this one, change for before 2010, and it tells us that it's significant, unsurprisingly, since the data is simulated to be that way. The difference with partial change of regime regressors is that they can be used with the seasonal differencing, which makes it easy to test for changes in seasonal pattern if you have established spec files, because all you need to do is add these seasonal regressors. And if you saw my talk with X13 SAM yesterday, X13 SAM will just add these seasonal regressors to your spec files just all in one go if you ask it to. It also doesn't need a lot of data beyond the test period in order to be used. You'll see why in just a second. Actually, let's show you why right now. So if this is the partial change of regime seasonal regressor here, blue is just where it's non-zero. If you apply a seasonal difference, this is only non-zero in the year following the series. If you also have a seasonal difference, it adds one additional quarter or month of non-zero values. So this partial change of regime with a seasonal differencing is really just testing, is there a change in the seasonal pattern at this particular point? It doesn't necessarily indicate that that pattern is going to be sustained after that change. So it's still good to look at other things, to look at graphs, to look at perhaps the full set of partial regime regressors once you've narrowed down your series to test using this partial test. The other thing is that whether you use the 0 before or the 0 after, it's going to give you the same exact difference matrix. The only difference is the signs of the non-zero regressors. So if we run our simulated series, either with the 0 before or the 0 after seasonal regressor, we'll get the same exact values, just with opposite signs. And in both cases, it indicates a seasonal pattern. Notice that we ran this with the seasonal difference, which is the difference from the full. There are some challenges in using these regressors to test for a change. First of all, we have, during these times of change, often a lot of outliers, a lot of level shifts, a lot of additive outliers, and that could really make an effect on these, on the significance of these regressors. If you don't have enough outliers accounting for some of those big changes, then these regressors might pick up a significant effect that's really just an outlier. If you have too many, it might not pick up the change at all. So you want to be careful with outliers. We must have been trying with a couple different options for dealing with the outliers, as the other speakers will talk to you about. Also, the date of the change to look for can be kind of tricky. Like, when do you start? Do you start when the pandemic started? Do you start when there's a new normal? When is there a new normal these days? Especially the volatility of a lot of our post-2020 time series. A lot of them are still looking really different, but is that a new pattern, or is it just like really different because everything's been crazy for the last few years? So some things to think about there. So you have a change. What do you do about it? There's a few options. You can use a shorter seasonal filter to get to the new level quicker. That's kind of the easiest approach. You can also take these seasonal factors and apply them directly to, take these change regime regressors and apply them directly to the seasonal factors. With a seat adjustment, if you just add these change regime regressors, it automatically will apply it to the seasonal factors. With an X11 effect, you can apply them, but you just have to be kind of sneaky about it and read in the regression matrix as a user-defined regressor that's marked as seasonal. There's instructions for that on the next slide that I'm not going to go over, but they're there for your reference. Finally, another option is seasonal outliers. If you see that the change is really only big in a quarter or two, a month or two, you can use the built-in SO regressor instead, or at least try it out. Really quickly, two more quick slides. These are the seasonal factors from seats. If we ran our example series with the change of regime, that's in yellow, or just with a regular seat adjustment. Notice that they wind up in the same place. Seats, when you include the change of regime, it just gets there quicker. And we see a similar thing here for X11 adjustments. Again, we always are winding up in the same place, but it's getting there quicker when we use the regressor instead of letting the seasonal factors, this is a 3x3 seasonal factor for the blue, do the work for us. So for that, with that, I'm going to turn it over to Laura to talk about her series.
All right. Thank you, Demetra. So I'm Laura James, and I work for the Retail and Wholesale Services Statistical Methods branch here at the Census Bureau. I mainly work on time series and seasonal adjustment for the retail and wholesale surveys, and I also provide some support for the services surveys. So I'll give a quick background intro on 3 different surveys that I work on, and then we'll get into the change of regime testing and some of our results. So I'll start off with the monthly retail trade survey, which is also known as MRTS. This survey provides month-to-month trends for sales and inventories of U.S. retailers and food service companies. There's actually 2 surveys here. So there's the MRTS, and we also have an advanced monthly retail trade survey known as MARTS, and that just provides an early indication of sales activities. So for example, in the month of September here, for the MRTS, we'll be releasing data for July, and then for MARTS, it will have sales data for August. These surveys publish on the national level, and some of the items that we publish are sales, inventories to sale ratios, we have measures of error, we have seasonally adjusted data, and our unadjusted data. And again, this covers the retail trade sectors, so that's NAICS sectors 4.4 and 4.5, as well as food services and drinking places, which is NAICS sector 722. This survey, MRTS, consists of about 13,000 companies, and it's a subsample of our annual retail trade survey. And then MARTS is a further subsample of MRTS, and that one consists of about 5,500 companies. And we redraw that sample every 5 to 7 years. Up next is the monthly wholesale trade survey, also known as MWTS. I won't go into this too much, just in the interest of time. So this is very similar to MRTS, where we're publishing those month-to-month trends of sales and inventories, but this time it's for merchant wholesalers, excluding manufacturing and sales branches. So again, all these data items are published at the national level. The main difference here is we're covering NAICS sectors 423 and 424. The survey consists of 4,200 companies or so. It's a subsample of our annual wholesale trade survey. And like the other one, we redraw that sample every 5 to 7 years. Lastly, there's QSS, the Quarterly Services Survey. This one provides estimates of quarterly revenue and expenses for U.S. Employer firms in select service industries. It publishes revenue, expenses, those measures of error again. We provide the seasonally adjusted data, similar to the monthly surveys. This is only on the national level. And this one consists of about 19,500 companies, and it's a subsample of our service annual survey. And like the others, we redraw that sample every 5 to 7 years. This is a slide of the NAICS coverage for QSS, and you can see there's a lot more here than the other 2 surveys. For the testing, I looked into 2 different change of regime regressors. So I had a March 2020 or 2020 Q1 for QSS, and then January of 2022 or 2022 Q1 for QSS. So I tested both of these regressors under 3 different scenarios. For scenario 1, I used our current production model. And under this one, I did allow for automatic outlier identification. We only look for additive outliers and level shifts. For the outlier span, for the monthlies, it only looks for the current year, so just in 2024. For QSS, that window's a little bit wider, and we do look back to 2022. Most of the critical values are 3.5, but sometimes during production review, we do have to go in and manually adjust and raise some critical values for certain industries. Under scenario 2, I removed all of our hard-coded, what I call pandemic outliers. So for MRTS and MWTS, that's anything from March 2020 onward. And then for QSS, it's 2020 Q1. For this one, for the automatic outlier identification, I set the span to start looking at the start of 2020 to the end of the data. And then I forced the critical value to be 3.5 for all of the series. And then for scenario 3, I took out all of the hard-coded outliers. And then I set for the auto outlier identification, it had an open span, so the whole series was fair game. And again, that critical value is set to 3.5. And one other thing to mention for scenarios 2 and 3, I didn't make any other adjustments to other regressors. So if there was a trading day variable or any holidays, anything like that, I didn't make any changes there. So for MRTS, I looked at 38 different published sales and inventory time series. With that March 2020 change of regime regressor, under scenario 1, there were 11 series that had p-value less than 0.05, so what we considered significant. Under scenario 2, there were 24 series that were significant, and then under scenario 3, we had 27 that were significant. With that January of 2022 change of regime regressor, scenario 1, under that condition, there were 13 series that were significant. Under scenario 2, we had 20 series that were significant, and then finally under scenario 3, there were 22 series that were significant. And here's just a table of some of the results. So this shows our series here. These are our sales time series. It has the F statistic and the p-value for each of our 3 different scenarios under the 2 different change of regime regressors. This slide here shows the remainder of the sales series and all of our inventory series. For MWTS, there were 44 published sales and inventory series that I reviewed. With the March 2020 change of regime regressor, under scenario 1, there were 5 series that were significant. Under scenario 2, we had 9 that were significant, and then under scenario 3, there were 9 that were significant. With the January 2022 change of regime regressor, under scenario 1, we had 6 time series that were significant. Under scenario 2, we had 5, and then again under scenario 3, we were back to seeing 6 series that were significant. And again, right here, I have the exact same table with the F statistic and the p-values for all the different scenarios for the different change of regime regressors. This slide shows our sales series. This one here is showing our inventory. And you can see there's a lot less red here than for MRTS. Lastly, for QSS, there were 175 published revenue and expense series that I looked at. Under the 2020 quarter 1 change of regime regressor, under scenario 1, we had 34 series that were significant. Under scenario 2, we had 54 series that were significant. And then finally, under scenario 3, we had 52 series that were significant. With that 2022 quarter 1 change of regime regressor, that scenario 1 had 28 series that were significant. Our scenario 2 had 46. And then lastly, our scenario 3 had 40 series that were significant. I'm not going to list all 175 time series for QSS. I do have that available if you're really curious. But just on the slide here, I have some of our revenue series. And again, just the F statistics and the p-values listed here. So this was really just a preliminary look into the change of regime regressors for these 3 different surveys. And we're really just beginning to explore the concept of these regressors and their impacts on these time series. And we would need to do a lot more research before we actually decide to start implementing any of these into our retail wholesaler services time series. With that being said, I'll hand it over to Sam, who will talk about international trade data.
And I just realized I was muted and I was talking the whole time. Thank you, Laura. Good afternoon, morning. My name is Samantha Nguyen, and I'll be discussing our research into testing and implementing the change regime in international trade data. So I am part of the seasonal team of the International Trade Statistical Methods branch. Our data is unique at the U.S. Census Bureau because it is compiled from automatic forms and reports filed initially with the U.S. Customs Service or directly with the Census Bureau for virtually all shipments leaving or entering the United States. Exports to Canada are compiled from Canadian import data. The automatic export system is a primary instrument used for collecting export trade data. Through the AES, the Census Bureau collects electronic export information. On the import side, the Census Bureau uses information collected by CPB, including the automatic commercial environment, automatic commercial system, and the E214 and their paper equivalent. The vast majority of the information is captured electronically, but there is still a small amount still collected through paper. After this data is collected, we seasonally adjust the data to identify and remove seasonal patterns in import and export value data by commodity, deflator for change dollar, and import and export value data by geographical area. Once we have seasonally adjusted the data and produce the seasonal factors, we will release the U.S. International Trade in Goods and Services Report, or the FT900, jointly with the Bureau of Economic Analysis. The FT900 report provides detailed information on import and export by commodity and end-use categories. The Census Bureau provides detailed information on more than 9,000 export commodities and 18,000 import commodities. This information assists the U.S. businesses in making informed decisions by tracking the global marketplace for their product and identifying possible opportunities to expand new markets. For the purposes of this research, we focus on the value or commodity series. The Census Bureau seasonally adjusts the merchandise trade data at the 5-digit end-use commodity category level, the most detailed end-use level possible. These detailed data are then summed to the 1-digit level for release with the monthly merchandise trade totals. The 1-digit level end-use includes food, feeds, beverages, industrial supplies and materials, capital goods except automotives, automotive vehicles, parts and engines, and consumer goods, non-food except auto, and other goods. This seasonal adjustment procedure identifies seasonal patterns at the 5-digit end-use commodity level. Adjustments are made at the 5-digit end-use commodity series for which significant, stable seasonality is identified. This data is divided into 269 series, which we review annually beginning in January. This data is from 2001 to 2023. We seasonally adjust the data revised 3 years back, so this year factors were applied to data from January 2019 to March 25, and the factors are projected for the upcoming year. Now that we have our data and models, we can proceed with the testing. We use X13 SAM to expedite the process of adding the change of regime and removing outliers. We tested 2 change regimes with dates at March 2020 and March 2021. For our first test, we removed outliers post and including the date. We then ran the models of auto outlier identification on. We then recorded the p-value of the change regime and any auto outliers detected. For our second test, we removed all outliers and ran the models of auto outlier identification on. We also recorded the p-value of the change regime and any auto outliers detected. So for our results, as you can see, we did have series that were significant. For seasonal change regime March 2020 with post-March 2020 outliers removed, there were 53 series that had a p-value of 0, and an additional 20 series had a p-value of 0.01. With all outliers removed, there were 49 series that had a p-value of 0, and an additional 17 series had a p-value of 0.01. You can see similar results for the seasonal change regime at March 2021. From these results, we narrowed down the series that could benefit from the change regime by looking at improved diagnostics and examining graphs. Let's look at one example. Here we have the series M4000, or imports of apparel and household goods, cotton air. You can see March 2020 is circled where a different seasonal pattern began to emerge. This was a great candidate for the change regime. Let's take a look at the model and how the change regime changed the series, or help the series. We have the original model and then the new model with the change regime implemented and an additional outlier. The model went from failed normality to normal and improved QS statistics. So what are our next steps? So for now, we have reviewed the top 60 and 7 series have benefited from the change regime. We're currently reviewing an additional 37 series ranked 61 to 269. And based on these results, we will implement these models for next year's annual review. There is a caveat, which is the 2024 data behaving well with the change regime, but at least we'll have a starting point with these models. And now I'll pass the baton over to Erin.
Thanks, Sam. Let's get to the right slide. There we go. Okay, so I'm Erin Rona in ESMD at the U.S. Census Bureau, and I'll be talking about testing for changes of seasonal patterns in business formation statistics, or BFS. So some background on BFS. It measures early stage business activity with a short lag. We release about 12 to 14 days after the end of the month. BFS is derived from applications for employer identification numbers, or EINs, and the IRS shares that data with us, so this is an administrative data product. BFS consists of 12 monthly series, 4 application series, 6 formation series, and 2 duration series. And here's a quick look at the seasonally adjusted total US business applications, that top line in gray. And then another series called high propensity business applications is the proportion in orange there. So we will focus on just one of those series, the top line business applications, or BA. This is the core series that includes all EIN applications made in the US. So that's 50 states plus DC, plus recently we've added Puerto Rico. There are exceptions for those filed without a business intent, like trusts, estates, tax liens, public entities, some other filings with little or no business intent, like personal tax or finance related filings, and some household activities. These are all excluded from the application counts. And we release data at different tabulations: state, region, national totals, and sector levels. We seasonally adjust at the most granular level, state and sector, and aggregate up to the region and US totals. I tested a change of regime at 3 different time periods there: March 2020, January 2021, and January 2022. So these tests add seasonal regressors that are 0 on and after the date specified. The models had no hard-coded outliers, only auto outliers were identified. We tested business applications at the sector level through June 2024. The first column tests March 2020. That means we are adding seasonal regressors that are 0 on and after March of 2020. And then we have the same test at 2 more time periods, January 2021 and January 2022. You can see the March 2020 time period results in the most significant sectors at 13 of the 19, using a p-value less than or equal to 0.05. Then there are 4 significant sectors when testing the January 2021 date, and just 2 at January 2022. And because of this, I focused on that March 2020 date where we have the most significant number of sectors. I tested an additional regressor at this date. This test estimates the full set of seasonal regressors and then a second set that are 0 on and after March of 2020. And again, we had no hard-coded outliers, auto outliers only. And one thing to note, unlike the earlier tests, this regressor cannot be used with seasonal differencing. Okay, so this first column of p-values is what we were looking at the previous table, the same values there, but the blue column has results from the additional regressor. The first p-value listed test seasonality post March 2020, and you can see they are all seasonal in that period. The second p-value tests if there is a change in seasonal pattern, and then we are really not interested in the third one there, so we can ignore that one. And here is a graph of the unadjusted data. The time series starts at July 2004, and this research was conducted on data through June 2024. These are total US business applications. I mentioned before that we are adjusting the data at the state and sector level, and then we aggregate up to the totals, but I wanted to show the total applications so you get an idea of what the unadjusted data looks like. And here is a graph of unadjusted data for sector 55, or management of companies. This was one of the significant sectors that showed a seasonal pattern change at March 2020. As far as the state's data goes, I tested the same regressors on state level data with similar results. We had 19 of 52 states significant with the March 2020 regressor. 11 were significant at January 2021, and just 3 at January 2022. And then here's a graph of not seasonally adjusted data from New York, which was one of the 19 significant states at March 2020. Okay, so much like the other survey areas, I do think further research is needed to determine if a change of regime regressor is a good fit. I'd like to have more time to look at models that include our production outliers to compare. Another thing to note is we're on a bit of a different schedule. The annual review period for BFS is actually starting next week. And so we've got to finalize our models in October, like next month. So those are used in adjusting November 2024 through October 2025 data. I do hope to have some more testing by our next annual review, so we have more information to decide whether or not adding a change of regime is appropriate. And here is the contact for each of us and links to our websites if you'd like to learn more.
All right, thank you. Thank all four of you. You guys finished a little bit early, so now we have plenty of time for questions. Just remind everybody you can ask a question of any of our speakers. That includes Demetra, so you can ask any of the five actually. Feel free to just jump in, or you can just raise your hand through Teams if you prefer to do it that way. But the floor is open for anyone to ask any of our speakers questions. And make sure to unmute yourself if you want to ask a question. Okay, Anna wants to ask a question. Go ahead.
So I have a question for the first presenter first. Thank you very much. Maybe I missed something, but you spot differences on M7, let's say low and high. But what happens if you have two different seasonal regimes, but both seasonal? So well, that wasn't so clear for me. And for the second presentation, I ask it later or do it now?
Sorry, you mean when I try to decide the type of the break, just to understand the question?
Yeah.
Okay, first of all, sometimes it may be very clear from the overlay graph if we have a seasonal to non-seasonal, but if I am in the borderline, I test M7 before and after with all the default options, and if I get, say, for example, with all the default option in ARIMA that is non-seasonal or 00011 or something not acceptable, then I try or the airline model or to put 011 to make the non-seasonal seasonal, and I try the M7. But I see how it goes. I mean that I may think, okay, a seasonal to non-seasonal break seems the best option. But if I try a seasonal to non-seasonal break, say that I have M7 before the break, say 0.7, and after the break to have, say, 1.6. And I do all the necessary steps, and I'm not happy with SI ratios, then I try to put RMX, to put seasonal to see what I like more. Just I make a comparison, but what I told was what is the first thing I try.
Okay.
Hope it makes sense. Sorry, does it make sense?
Yeah, see, it does. Okay, thanks.
Thank you.
Thanks a lot.
Was there another question?
Yeah, so I just have a quick question for the second presentation, to thank you very much as well. So here, to understand this well, when you measure the effects of your regressors, then you will allocate them to the seasonal, just as if you were using a seasonal outlier. And so did you try to compare with seasonal outliers? Like the classic ones when you have a compensation on every period for the spike in a given period. And and so the detection, from what I understood, has until now is always ad hoc. It's expert analysis So are you working on some automatic procedure for detection or not? Thanks a lot.
To answer your last question first, no, there's no work right now on any automatic detection of this. It's so complicated with all of the outliers and all of the volatility that tends to happen in these times. I think you really need a person's eyes on it. Maybe other people would disagree. I don't see it happening. And as for your first question about seasonal outliers, I think we actually have a couple of seasonal outliers in production. Don't quote me on that, but I think it's possible. This second thing about using the change of regime and applying it directly to the seasonal factors, that's not something we're doing in production. It might be if we find any candidates that we really think are good fits for it, but right now no one is doing that in production as Census. We're just using it right now to test. We might if we really think it's a good idea, but we'll see. And plus the question then is, do we use it just for the modeling section in order to get better forecasts, to get a better model fit, or do we actually want to do that next step and apply it to the seasonal factors to get that sudden seasonal change? That's another question that we're going to have to think about, because for a lot of our series, we think that just using a short filter is doing an okay job.
Yeah, thanks a lot.
All right, thank you for those questions. I think Brian has a question.
Not so much a question, but to tag on to what Demetra was saying about the SO outliers. At one point, X13 had SO outliers in its automatic outlier detection, and my experience with that was that it over-identified SO outliers in the beginning and the end of the series. So yeah. you would see a whole lot of examples of where you would have like either in the first or either in the second year or like a year next to the end, you would have like you'd have an overabundance of SO outliers. So that influenced us to just remove it from the automatic outlier. So I'll reiterate what Demetra said. It's the problem of automatic identification of seasonal breaks is very difficult. I mean, one could probably like fit a bunch of seasonal breaks and look at AIC and see what the differences might be. But I mean, it's if you're trying to integrate it with with the outlier identification of other outliers like TSs or TCs or whatever, I mean, I think it's a very difficult problem. Doesn't mean that we don't like try to research it, but I mean, I honestly think it's a very difficult problem.
It's such a sudden shock to the seasonal factors. We like to really have an explanation for it if we're going to use it. Like for the series that I know was using it, was I think it was a manufacturing series, and they had a reason why one of these quarters was all of a sudden, or one of these months was all of a sudden really different because of some changes in holidays or something like that. So when you have such a good explanation to use it, then I think we're much more comfortable with it than just the data looks like there's a change.
Okay, thank you. I think Benjamin has his hand raised. We have about 4 more minutes.
Hi. Yeah, thanks for the presentation. I have a question for the second presenters. Maybe Demetra, you can answer this. I might have missed this since I missed a bit of the beginning, but are this change of regime regressors, are they appropriate for series where like there was a change, but maybe the series returned to its normal patterns after a certain period? Like I've worked on series where maybe during like 2020, 2021, things were really disrupted, and then after they've returned to their normal level. So do you think these would be appropriate for series like that, or would you maybe introduce like another change of regime regressor for the ending period?
I mean, it depends on what that sudden change is looking like. Like, does it look like you jumped to a different level for a few years and the seasonal patterns seem to be the same over that level? Because that's really when you want to maybe try it and then phase it out. I could see you creating a like custom regressor that's only non-zero for that time period, although you wouldn't be able to have seasonal differencing, so maybe you wouldn't like it that much. Yeah, I mean, I would be kind of wary. It's always worth a try, but I'm not sure how well it would work when you have, in times of such volatility. Like, are we really jumping to a new pattern and then going back to an old pattern, or are we just crazy unusual and all sorts of weird things are happening, and just a lot of additive outliers and temporary changes and some level shifts might really be the better fit.
Okay, thanks. Makes sense.
Can I add on to that?
Always, Brian.
Yeah, I'm wondering whether you could just do you don't know that you could do you can't do this with the basic, but you could create your own variable that essentially has the change of regime for a specific period and then zero out the end where you think there isn't one, and try that and look at whether that affects forecasting or AICC or what. But I would also try shortening the filter. I would look at what the ARIMA model is telling you about the seasonality in the series. I have to say, when I looked at the first talk, I was kind of cringing about using M7 for that. I might look at like modeling the two sections and looking what the seasonal MA is telling me. Maybe the seasonal MA will tell me that, this has a much more stable seasonality than the other period. But I think you need to have more data to really do that.
All right, well, thank you for that. Thank you for all of your input. This session closes at 11:15, so technically we have 1 more minute. So I will close everything out. Again, thank you all for joining us in this session. The next session